Hello everyone, now we are gonna start our next chapter and the name of the chapter is trie. So trie is a new data structure which we are gonna study in this session. So talking about trie, you can consider trie as a type of a tree. It is a tree type. So it is a tree type data structure, and up to now we have studied different types of trees, like we have studied general trees, binary search trees, AVL trees. We have seen this sort of trees, and I have given you the basic underlying explanation about red black trees. So we have studied what is binary tree, what is binary search trees, properties in it, and we have solved plenty of problems in it. Now we are gonna start a new type of data structure which is based on the concepts of trees, and the name of the data structure is trie. Now you might ask why we use it, why we have introduced. We have so many things, right? We have BSTs, we have AVL trees to study, we have binary trees, and we can solve the problems using those data structures, right? Why we have introduced a new type of tree type, that is trie. Why we have introduced this, talking about why we have introduced this. So to understand the question why, you need to understand that when we perform some questions, let's say I am performing a question based on string, and in the string the user has asked me to perform some complex operations. Then when you go for general method, when you go for brute force approach, then what will happen is that the time complexity will be so big, you can say huge. It will not be efficient. So brute force approach or general string approach will not give you efficient time complexity. So for that, to tackle that, we have introduced the concepts of tries, and by using tries we can solve complex string questions. So the main motive of introducing a new data structure, a new tree type data structure, is because to solve around 90% of problems can be solved. Complex string problems can be solved using the data structure tries. What we will do, we will create a trie and we will insert these string characters into string array characters into my trie, and by doing that we will see that when we solve the questions, the trie data structure will give a lot, you can say a better time complexity when compared to brute force approach. So this is the main one of the reasons why we have introduced the new concept, and we call trie data structure as prefix tree. So we also call this trie data structure as prefix tree. Now what is prefix? If you recall some our English language, then you can see that, let's say I'm taking a alphabet, I'm taking a word apple. Okay, in this A is a prefix, after it app is a prefix, after it ap is a prefix, after it app l is a prefix, after it app le, whole word will become a prefix. So these are the prefixes. So what we will do is that in order to create a tree for this string, we use trie data structure. So for example, let's say user has asking you some complex terminologies. In the question we are gonna perform some complex things on strings, and when we see some complex operations that are going on string, then it is an indirect implication that that particular question can be solved easily through the concept of tries. I hope you have understood why we have introduced the concept of tries, and we also call this as prefix tree. And one more thing is that there is a quality of tree, this trie data structure, that is, it is very, you can say the retrieval time, the speed of this trie is very high. It means that whenever you want to perform some operation, let's say I want to perform add or search operation, then it will give me a much efficient time complexity when compared to general trees and general like BSTs. All the trees, when compared to that, my trie data structure will be so much efficient, and because of this we call this highly retrieval trees. We call this as highly retrieval trees, and from this highly retrieval trees we have extracted the name tries. Okay, so we also call this data structure as highly retrieval trees, and some programmers also call this data structure as digital trees, because when we perform some digital operations on a set of, you can say in maps, when you know one node is connected to different nodes, one location is pointing to different locations, when compared to your location you can find all the locations. So internally what is happening is that it is creating a trie data structure. So because of this we call this data structure as digital tree data structure. So this is about why we have introduced. Now let us talk about what this trie data structure. So if you recall binary tree, let us talk about binary tree. So if you recall the concept of binary tree, each node will have at max 2 children. It means that for a particular node, if it is a parent, then it will have at max 2 children. Similarly, a trie is a k-array data structure, k-array tree. So what is the meaning of k-array tree? Here you can see that a binary tree is a tree in which the children's at max should be 2. You can see that here in binary tree, the maximum children are 2 and we can have 1 children, 0 children, or at max 2 children, right? This is the condition of binary tree. Similarly, for a trie, it can have kth children, k number of children. For example, let's say this is my node, and if I represent trie, then it can have 1 children, 2 children, 3 children, 4 children, up to it can have k children. So this is the difference between a binary tree and a trie. Trie is a k-array tree. It means that for a particular parent node, it can have k elements, and k can be anything from 0 to infinity. It can have anything, not exactly infinity, but it can have any large number. Okay, so this is about what is a trie. Trie is a k-array tree. And one more thing I have told you, that the time complexity, we call this data structure as highly retrievable data structure, because the time complexity for trie is very much less when compared to my binary tree, my BST, AVL trees. When compared to this, the time complexity will be very less. Now you might ask why the time complexity is very less. Because if you recall the concepts of a tree in general, you will come across that time complexity is totally dependent on height of the tree. That is, you can represent time complexity as a function of big of h. And if h increases, h is the height of the tree. If h increases, then the time complexity will also increase. Is it correct? If h increases, then the time complexity of the tree will increase. And if the time complexity increases, then overall operations that we gonna perform, whether it might be search operation, insertion operation, delete operation, whatever the operation, if we wanna perform in a tree, it will take, you can say, more time when compared to a trie. Now let us understand. I have told you that time complexity of trie is very less. How and why? What are the things that are going beyond that makes this trie data structure efficient when compared to a binary tree? So to understand that, let us take example that I am having 10 nodes and I am creating a balanced BST. I wanna create, because I know that if I create a balanced binary tree, then the height should be minimum. Okay, so here for 10 nodes I can create a balanced tree, a balanced binary tree as this is my root node, 1 element, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is the height of the tree? The height of the tree is 1, 2, 3, 4. Yeah, 4. The height is, you can say, height is 4 and the time complexity will become big of 4. Now let us talk about an unbalanced tree, a skew tree basically. So if I consider a skew tree, then the number of nodes will be 1, 2, 3, 4. It will form a skew data structure up to 10 nodes. Okay, 10th node it will form a skew structure. And what will be this height? The height of this skew tree, skew binary tree, or you can say whatever the tree, skew tree will be big of 10. It means that the height of this particular skew tree is more. That is why I am getting my time complexity more. Now let us talk about a trie. Here comes the magic of trie. So if you build a trie, then what will happen is that, let us build a trie. So this is my root node. Let's set one node, 2, 3, 4, 5, 6, 7, 8, 9, right? And basically let me add 10th node. So you can see that this is my root node, and this 9, I am adding 9 children. So the total number of nodes in my trie will become 10. And what is the height of it? If you see, I am having root node and this root node is having 9 children. So the time complexity of this will become big of 2. So which one is efficient among these three, between a balanced binary tree, a skew tree and a trie? Which one is efficient? you can clearly see that the try is much more higher, much more efficient. The efficiency of try is much more higher when compared to a balanced BT, that is binary tree and skew tree, right? And because of this property, the retrieval, the searching, whatever the operations we are gonna perform will become so efficient, right? I hope you have understand. Now let us talk about one more thing, space complexity. So talking about space complexity, you can see that the try data structure is very bulky, and because of this bulkiness, the time complexity is not good. So one thing you need to remember, the complex order-wise complexity for try is that the time complexity is very efficient when compared to any other tree. My try data structure will be efficient in terms of time, but it will be worst in time in terms of space. I hope you have understood what is a try. Now let us understand how we build a try. So I will have a array. So let me remove all the ink here. Okay, now user has given me array, and I have told you that we perform operations for strings. Mainly we create strings like this for a try, and because of this try data structure, my string problems will become so easy. So let us consider that user has given me this string array. Now for this string array, I will create a try and I will show you. So what will happen in my try, I'm gonna create a try for this structure. For this words array, I will create a try. So initially in try, there is a concept that root node will always remain empty. So whatever the try might be, the root node should always be empty. Now after, I will add a, I will iterate through each and every. This is my word 1, word 2, word 3, word 4, word 5. So I am having 5 words, and each word will have some characters in it. Okay, so I will iterate each character of different words. So first of all, I will iterate through a. After it, I add a on the next level. After I will go to P, and I will add the P character on A's next level. So I will add P here. After it, similarly I will add again P. After it, L. After it, E. Now the word 1 is completed. So when the word is completed, when I reach end of word, when this becomes true, then I will retrieve back, I will come back to my root node, and I will start iteration for the second word. Word 1 is completed. Now I will go to word 2, and I will take the characters, and from the root node I will check whether this particular character exists or not. You can see that A is already existing. So if A is existing, then I will not create a new child node. I will go to that level. Okay, after that I will add P. P is already existing, so no need to add. Similarly, this P is already existing. So here end of word will become true. If this is true, then come back to root node. Now I will go to my word 3. In word 3, M is not there. For root node, there is no child node as M. So I will add M. After it, A, N, G, O. I will keep on adding level wise. Okay, I will add O. Here the end of word will become true. Now I will move to my word 4. For I will come to my root node. You can see I will come to my root node. Now for this root node, M is already existing as a child. After that, A is already there, N is already there. So here end of word will become true. Now if end of word is true, then I will go to my root node, and for word 5 I will iterate. So here this is my root node. Now I will add W. W is not a child, that is why I am adding. After that, 0. After O, M, A, N. Like this we will create a try. I hope you have understand. Now let us talk about the node structure. In order to create the data structure, if you recall the concepts of linked list, we first of all we have defined the node. Each node will have a data and next. Similarly, a binary tree node will have node left, node right, and it will have some data. Similarly, the try node, the try which we are creating the node of it, will have two things. The first is an array of 26 elements, and in this array I will store the children values. I will store the children nodes in it. So what I will do is that I will create a class node. In that I will create node type array of 26 size. Okay, and here I will store, because I am only considering from small a to z, small z, I am only considering these characters. So here the total number of characters would be 26. So I will create a size of 26 array, and I will check for this root node. I will tell you in insertion how the insertion will happen, but for now, if this is a root node, then I will create a node will have 26 array size 26 array as its part. After that, end of word, and I'm gonna initialize it with false. Okay, and all the elements would be initially null. So this will be my overall structure of a particular node in try. So this is the structure. Here you can see that I will have node array of size 26. After that, I will create end of word, and I will initialize the end of word with false. Right, now let us code the node in my Java program. So first of all, I'm gonna import my packages. Import java .util.star. After public class tries is my file name, that is my, I'm giving my class name try. After public static void main string args. Now in the main program, first of all, in the class I'm gonna define my node. So class, here let me give static class node, and in this, first of all, what I will have a node of size 26. So node, let me give here children. So I'm gonna store the children values, right? So I will write children of array is equals to new node of size. Here I'm gonna store 26 characters from A to Z. So I will give size as 26 because I'm gonna store from small a to here small z. I'm gonna store the characters like this. Okay, now after that, what I will do is that I will create a boolean variable, boolean end of word, and I'm gonna initialize it with false. Okay, now after that, I have created my array. Now I'm gonna initialize the whole array with null values. If they are children's, then I'm gonna initialize all the nodes with null value. Okay, so I will run a loop for, let me create a constructor first. So node here. Okay, now what I will do is that I will run a loop for int I is equals to 0 and I should be less than node, that is children dot length, and after that I'm gonna increment I plus plus. In this, what I will do is that I'm gonna initialize each index with null. So children of I is equals to null. Okay, this is how I'm gonna create my node. After that, in the main program, I will create, in the overall program, in the old class, universal class, I will create a static node type and root, and I know that in my try the root will always be null. So here I will give public static node root. So root is equals to, I will create new node, right? So this is the overall structure of my node. Now let us understand how we can add elements in my try. So let us understand how the insertion works for my given try. Okay, so for first of all, let me take only this characters only. I will take not this because I have shown you the diagrammatic representation of this. So in order to avoid the overall length, I'm gonna remove some mini elements. Okay, so what I'm gonna do is that first of all, I will tell you how a try will get inserted. I have shown you how a try will be created, how a try will look like a particular node. Now let us talk about how we can insert a particular node, you can say create a particular node in my try. Okay, so here let us consider that this is my root node, and I know that root node will always be empty. And if you consider a node will have 26 array, right, of 26 array size. After that, it will have boolean variable end of character. So my root node will have an array of node 26. So here I will have 26 characters, 0, 1, 2, 3, 4 up to like this 26 characters, right, from 0 to 26. Now at each and every index you need to understand that I am gonna store characters. When I add a child, I will store the characters in this particular array. The node which I'm gonna store, I will add that particular node into this particular array, and this will give me that this at this particular location child is already existing. I don't need to add again. Here you can see that when I am adding a pple, this is my node. Now for the second word I am adding a, you can see that I'm checking A and I'm not adding A again. A is already a child. If it is a child, then no need to add again, right? So what I'm gonna do is that I will check, this array will tell me whether a children is existing or not. If it is existing, then I will not duplicate, I will not create a duplicate, I will not create a child. I will continue to the next level. Okay, so what I will do is that this is my word 1. I'm only considering I'm removing 2 words in order to avoid the overall complex diagram. I don't want to write the complex diagram because I'm going to write the pseudocode also. So in the same slide I'm going to write it. Okay, so this is my word 2 and word 3. So what I will do is that I will iterate through each and every character of that particular word. So here for this particular node, for the root node, end of word is false and I have created an array. Now what will happen is that it will check whether A is existing in the character, in the whole array. We know that A is not existing, right? Because at the 0th index, A will get stored at 0 index. A will be at 0th index, B will be at 1st index, similarly Z will be at 26th index. Okay, now I will check at 0th index what is the value. Here you can see that I am initializing all the array elements with null. So here null will be there. If it is null, then remove null and add A. So I will add A as a child and I will go to next level and I will check for this particular array 0, 1, 2, 3 something, and the next character is P. So for this node at pth index, it will have again null because it doesn't have any children. So I will add P, after it similarly P, L and E, right? And here end of word will become true. If it is true, then recursively come back or break the loop, come back to the root node. Now here for this particular array, A is filled. Here I am storing A. Now after it, I will move to my second word, that is M. Let us consider that this is the M index. So initially at M index, the element I am storing is null. If it is null, then add that particular character of that particular word as a child. So I will add M as a child. After at that particular position of null, I will remove and I will add M. Okay, similarly go to the next level, immediate next level, A, N, G, O, and this next level processing will continue until I get a end of word. So here end of word will become true. If it is true, then return back to the root node. Okay, so I will come back to the root node. Now for this word 3, let's say this is the W location. So I will check for this W character. Here I will have null because I don't have any child which value is equivalent to W. So if it is null, then remove that null and add W in it. So here add W, O, M, A, N, and end of word is true. End of word is true. If it is true, then return back to the root node. That's all. After that, you can see that I don't have any words to add. Like this, I will create my whole array. So what I will do is that, let me write the pseudocode here. So the pseudocode will be, first of all, I will create a current node. Initially, I will create a current node. Here I will store root value, right? And after that, I will run a loop for int I is equals to 0 to, or here let me give level. So level is equals to 0 to my word, whatever the word length will be. Here you can see that the word length is 1, 2, 3, 4, 5. So the word length I will go, and until I get my end of word, I will keep on running this loop. So my level should be less than word dot length. In this, what I will do is that I will check whether I am having children or not. If I am not having a children, then I will create a new node and I will add at that particular index, I will add that node, else I will continue. So if children of that particular index, children of this particular level is null, if I am having null, that is current, here not right. So current of that particular level is null, then immediately create new node, right? If not, then change the current value, move to the next level. So current is equals to current dot next, right? Current dot, this will represent the next level. So this is the overall idea, this is the overall pseudocode of this thing. Now let us code this thing. So in the main program, I have created my array which I have taken as example. Now after it, on top of my main program, I will create my insert functions, public static void insert. So here I will pass the word. So whatever the word I am having at that particular in the array string I will pass a particular string in my insertion function. So I will add string word. Okay, now in this, first of all, what I will do, the step one will be I will create a current node. So node current, and I will store the initial value with root. So I will store it with root. After that I will run a loop. Here I will create I will run a loop for int level is equals to 0, and I should be, that is level should be less than my word dot length. Now after that I will create, I will increment level value, right? So I will increment level value. Now in this I need to check whether the current particular index is null or not. If it is null, then I will add a new node at that particular corresponding index. I need to add a new node. Whatever the node I am creating, I will add it. So what I will do is that if my curr dot children of this particular level, that is my here let me store the character index. So int idx is equals to word dot char at particular level minus a. So what this will give? This will give me a integer value. So what is the integer value here? This word dot caret will give me a character. Similarly, a will also be a character. So if you recall some concept, that is let me write it here. I will write this thing here. So if you recall, then in strings I have told you that a minus a will give you 0, right? And b minus a will give you 1. Similarly, c minus a will give you 2. So if you subtract a character with another character, it will give you a integer. And what this 0 will represent? 0 will represent a character, that is the first index, and b will represent the bth index, that is second index, and this 2 will represent the third index, that is c character. Like this, the subtraction, whatever this subtraction returns me, if at that particular child value, if it's null, then I will add a current, that is dot children. I will create a new node. So at that particular children location, new node, and I will give the whatever the character I am having, I will add it. So I will add my word. So at that particular index I will add my new node, whatever the node I am creating, I will add it here, right? Okay, now if it is not the case, then I will move my current pointer. So current is equals to curr dot current children. So current children, and at that particular idx I will move. Now after iterating all the characters, I will reach the end of the word. So if I have initialized end of the word as false, so I will change the end of the word. If I am reaching the end of the word, then I will make it true. So here curr dot end of word will become true, that's all. So this will be my insertion operation. Now in the main program, what I will do is that I will run a loop for int I is equals to 0 and I should be less than word dot length, and for each and every word I will call my insertion function, and I will pass my here word array. So I will pass my word of ith element I will pass. So here this word of ith element will get passed here, and in the program what I am doing is that first of all I am in the step 1, I am creating a current node, initializing with a root element. Now after running a loop for level is equals to 0 and level should be word dot length, that is the end of the word. If I am reaching the end of the word, then I will come out of my function. Okay, so in the loop I am checking at that particular index, whatever this index will give me, at that particular index if I am having null, then I will add a new node here. If it is null, then I will add a new node, else I will continue. This is what basically I am doing. This is how we will create a try in our program. Now let us talk about some other operations. Now let us talk about how we perform search operation in our try data structure. So let us consider, I have only considered 3 words because I don't want to make my try too big. So this is my word 1, word 2 and word 3. So first of all, let us build the try for this 3 words, and after that I will give you a key, and we need to tell that whether that key exists in my try or not. So here let us build our try. This is the root node. A, P, P, L, E, and after that my second word is already existing here, here. So end of word here becomes true. After that here also end of word will become true. Now here the word 3, word 1 is completed, word 2 is completed. Now word 3 will be M, A, N. Now this is my whole try structure. Now let us consider that user has given me key is equals to man. Now I need to tell that whether this particular word exists in my try or not. We know that this word is already existing. If it exists, then I will return true. If it doesn't exist, then I will return false. So what is the approach is going to be? How we will check whether a particular word is existing in my try or not? So what I will do is that, first of all, I will run my loop. Like said, this is my key, right? So M, A, N. So I will run a loop for my key characters. So I will come to my this M and I will check for the root node whether I am having a children, which value is going to be M. Here you can see that the child value is M. If it is M, then go to that level. So I will come to this level, level 1, level 2, level 3, 4, 5, 6. So I will go to level 2, right? In level 2, I will check for the second character is A. So I will check for M node whether I am having a children that is equivalent to A. Here I am having A. So I will go to my third level. So on the third level, the third character is N. So I will check whether this third character is existing in my third level as a child node. So for this parent node, it is having a child node as N, and I have iterated all the elements. If I have iterated all the elements, all the characters, if I have iterated and end of word is true for this particular try node, if the end of the node for that particular node, if end of word is true, if this first condition, that is iterating all the characters in my key, and in the try for that particular node, its end of word is true. If this both conditions are true, then and only I will return true, else I will return false. For example, let us consider that I am having key is equals to M, A. Now here you can see that M is already existing. After that, A is already existing here. So I have iterated all the elements, but it is not end of word, because I am not having, you can see that here I am not having any word which is equivalent to MA. So if and only if these two conditions become true, then and only I will return true. Okay, now let us talk about the pseudocode of it. Now talking about the pseudocode is going to be very similar to insertion. So in insertion, what I used to do, I will check child is existing or not. If yes, then I will continue. If not, then I will create a new node. Similarly, here what I will do is that I will create a function, public static boolean type function, because I'm gonna return true or false. Now in that function, I will create a current node, initialize it with root. After that, run loop for key is equals to 0, for my I is equals to 0, and I should be less than key dot length. So I will iterate through key dot length. Now I will check if my current of that particular index is equivalent to is equals to null. If I am having any for this particular index, I am having children as null. For example, let's say I am having a key as Thor. So you can see that in the try, I am not having even the first character, that is the first character is T, but on the try structure, I am not having a character T. So if that is the case, then I will return immediately false. Else what I will do is that I will move my pointer. So current is equals to, I will move the pointer to next level. So next level, right? And finally I will return if my end of word is true. If end of word is equals to true, then and only I will return true. This will be my overall pseudocode. Now let us code this thing. So here I'm gonna create a function, public static boolean type function, boolean, and here let me give search, because I am searching a particular element. Now here the user will give me a string key. First of all, what is my step 1? Step 1 is to create my current node. So node current and initialize with root node. Now after that, run a loop for int level is equals to 0, because I will go level wise, right? On my try I will go level into my level. After that, level should be less than my key dot size. Now key dot length, after that level plus plus. Now in this, what I will do, I will check for, first of all, before calculate, let me calculate my index. So int idx is equals to my key dot character at that particular level minus a. If this particular character is not existing, then I will return false. So if my current dot children of this particular index is null, it means that this particular character, for example, my key is Thor, and I know that T is not even existing in my given string. If that is the case, immediately return false. Immediately return false. Now after that, if this is not the case, then I will move my current pointer. So current is equals to current dot children of ith index. Right now after that, I will return true only if my end of word is true. If end of word is equals to true, then and only I will return true. Now after that, here let me give a search function before. Let me print system.out.print, and I will call my search function, and in the place of key, let me give app. So if I run the code for app, you can see that in the array, string array, app is existing. So indirectly, in the try data structure, my app will exist. If it is existing, then I will return true. If not, I will not return true. So here let me save, and if I run this output, then my output should be true. So let me save and run. It is showing some kind of error. Okay, in line 7, where is line 7? Here I need to give a closing bracket. Okay, now let me save this thing and run again. End of word, here end of word is equals to false, and here I need to give current dot end of word, because I am having in the class node, I am having end of word, right, not a general variable. So let me give, you can see that I got the output as true. This is how I will check whether a particular character is existing in my try or not. So up to now, I hope you have understood how we can search a particular element and how we can insert a particular elements into my try. Now if I give some random input, let's say I am giving Batman. So if I give Batman here, then it should return me false, because in the word array I am not having a character which is equals to Batman. So if I run this, then this should return me false, and the output is false. So this is how we will search and insert. Now let us do some interesting questions. The name of the question is word break problem. So in this, user will give me a string array and a key. Now I need to break my given key into different parts, and I need to check whether that particular key is a word in the word array. If it is a word in the word array, then I will return true. If it is not, then I will return false. This is the basic asking of the question. So what is the basic asking? User has given me word array, and in the word array I will store various strings. Okay, now after it, user will also give me the key, and I need to break my key into different parts, and I need to check whether this particular word, after breaking, I am getting whether this particular word is existing in my word array, that is my string array, or not. If after breaking, if all the words are existing, then I will return true, else immediately I will return false. For example, let us take that the given key is I, like, Sam, sung. So here you can see that the first character is itself a word, right? This is word 1, word 2, word 3, word 4, word 5, and word 6, right? So here in I, like, Samsung, you can see that this I is related to word 1, and this like, this whole thing is a part of this word 2, and this Samsung is a part of word 4, is word 4 basically. So if whole key can be divided, can be break down into different words, and this different words is already existing in my array, then I will return true, else I will return false. Now let us talk about the approach of this question, how I'm gonna do this question. So what I will do is that, talking about the approach, first of all, the step 1 will be, I will create a try for this structure. So let me create a try for this. I think the try will become something huge, but let me create it. So here the root node, and I will store I. After it, go to the next word, L, I, K, E. After it, S, A, M. So word 1 is completed, word 2 is completed, word 3 is completed. Now word 4, S is already existing, A is already existing, M is already existing. So I will start adding from S. So S, U, N, G. Now after it, mobile. So mobile, let me add it here. M, O, B, I, L, E. Now the last word, that is word 5 and word 6. So ice, for ice, I, C, E. So this is my whole try. So this is looking kind of complex, but if you understand the overall question, it will become so easy. So what I will do is that I will call my insertion function for this whole array. So I will run a loop, and for the whole word array, I will pass the words, each and every word, and my insertion, I know how to insert elements, so my insertion function will take care. So first step is create a try for my strings. For the given strings, create a try, and the second step will be I will take my key and I will break it down into two different parts. So here this is my key, right? I like Samsung. So first of all, I will take the first character and I will consider the rest of the other characters as separate part. So my first character is one part and all the rest of the characters will become part 2. So this is my part 1 and part 2. I am breaking down my two parts into my given key into two different parts. Now I will check whether I is existing or not, and whether it is end of word for this particular character, end of word is true or is not. So you can see that here end of word is true, right? So for this I, the end of word is true. If end of word is true and it is existing, if it is existing in my tree, and for that particular node if end of word is true, then what I will do is that I will return true for this particular element. Now after that I will recursively call for the rest of this array. So for this LIKE SAM SUNG, I will take this word 1 and I will consider this all the elements as second part, and I will consider L as a part. Now you can see that L is existing in my array. L is existing in my array, but the end of word for this node is false because it is not end. The end of word for this character is E. So here end of word will become E. So here if that particular character is existing in my try and end of word is false, then I will take the next character. This is my part 2, right? So in the part 2, in the second part, I will take the next character, add it in the part 1. So what I will do is that I will recursively take the next element L I, this will become my part 1, and KESAM SUNG, right? So this will become my part 2. Now I will check for this LI whether this is existing. L is existing, I is existing, but it is not end of word. So what I will do is that I will add K here. So LIK, and I will recursively search for my second part. Okay. Now for this I will see L is existing, I is existing, K is already existing, but end of word is not true. So recursively again break that part into two array and add the next element, add this character into your array. So what I will do is that I will add LIKE. This will become my first part. After SAM SUNG, this will become my second part. Now for this first part, whether this is existing, it is existing, and end of word is also true, right? Because the last character is E. For E the end of word is true, so this will also return me true. Now like this, if all the breaking down, this will return me true, this has returned me true, and if also this return me true, then and only I will return true. If any of the case has returning me false, then I will return false. This is how I will do. So the first step is create a try for the given word array. Now second step is break down your key into two different parts. For the first part, check whether that particular character is existing in your try or not. If it is existing and end of word is true, then return true and recursively call for the rest of the second part, right? Like this I will do. Now let us code this thing. Now in the main function I have created my given array which I have taken. After that I have called my insertion function for this whole array. Now after that I have taken the key, I will search for this particular key, this key exists in my word array or not. So here I will create a function public, let me create a function public static void boolean, public static void boolean break word. So the function name will be break word, and user will give me key string key. So string key, and I need to check whether this key exists in my whole array or not. So what I will do is that here I need to give public. Okay, now what I will do is that in the program, first of all I will run a loop for int I is equals to 0 and I should be less than key dot length and I plus plus. In this I will check whether the character is existing or not. So if I will perform search operation for this particular key dot substring. So for the I am breaking my array into two parts, right? So for the first part I will call my string. I will break it down my string into two different parts, and the first part I will call search operation, whether this particular character is existing or not. If search operation returns true, then I will recursively call for the next part. So here substring, and I will give my from 0 to ith element. So I will add I after L, I, K, E. I will keep on adding like this, and this is the substring function which we have studied in string chapter. Now if this returns me true and let me remove this bracket here. Okay, and I will recursively call my word break, my break word function, break word function for the rest of the key. So key dot substring for rest of the array. So if this 2 returns me true, then I will return true, else I will return false. Okay, return false. Now what will be the base case for this? The base case will be here I will check if my key dot length is equals to 0, then I will return true. What I am doing in the program is that first of all I am checking this will become my base case. If key is 0, then I will return true. It means that the whole key is null and null node is my root node. So I will return null. Now after true, now after that I am running a loop for the key, and in that I am breaking my string into two parts. For the first part I am calling my search function, and for the second part I am calling recursively for the second part. So for the first part I am breaking my string into two parts, right? So this first part will go to for searching, and this second part will go recursively for again recursively call, and it will check, and if these two things return me true, then I will return true, else I will return false. Now in the place of here system.out.print, now let me in the place of search let me give break word. So break word, and I will give key. Now let me save and run. Now if I save this and run, then my output should be true. Now let me see. Okay, now let me save and run this. So you can see that I got the output as true. Now if I give some random values, let's say I like sun. So if I give this, then we know that this particular word is not existing, because yeah, I is existing, like is existing, but sun is not there. So my break word problem will give me false. Like this is how we will check whether a particular word is existing or not. Now let us talk about another interesting question. The next question, the name of the question is start with problem. So in this we need to create a function boolean starts with prefix for a try. So for this given word I will first of all create a try, and I need to check return true if there is a previously inserted string word that has prefix, and false otherwise. So what this means is that, let's say this is my try, right? Let me create a try. Let me here this is the try, somewhere I have created this try. Now in the given try data structure I need to check whether the given prefix word is a part of it or not. If it is a part of it, then I will return true. If it is not, then I will return false. For example, let me create a try here. So a p PLE, right? After that MANGO. Similarly WOMAN, woman. Now in this you can see that A is existing, after that P is existing, after again P is existing. If all the characters is existing in the prefix and the word, then I will return true, right? Else I will return false. For example, if you see the second example, M is existing, but for M its child value is A, not O, right? So because of only this characteral difference, I will return false, because this word is not a prefix, it's not a part of the trie, right? I hope you have understood. And the only difference between this word break problem and start with problem is that in this we will check whether it is a part. I will not check whether it is an end of character. If end of word is false, even though I will return true, right? I don't need to check whether it is a complete word or not. But in word problem, I will check whether it is a complete word or not. If it is a complete word, then and only I will return true, else I will return false. Okay, so let us talk about the approach of this question. So talking about the approach, first of all, what I will do is that I will create a trie. I will create trie for this given structure. Now after creating trie, I will run a loop. I will run a loop for prefix. For prefix elements, I will run a loop. I will go to A, after P, after P. Now I will see for that particular character whether that character is a part of trie or not. If it is a part, then I will return true, else I will return false. This will be my overall approach. So if I write the pseudocode of it, then first of all I will create a current node root. Now after that I will run a loop for I is equals to 0 to my given prefix dot length. So prefix dot length, and at each and every index I will check whether the children value of that particular index is null. It means that that particular index, this particular character index is not a part of my trie. If this is the case, then I will return false, else I will return true. So I will return false. After running the whole loop, I have got into the end of the function and I didn't find anything. It means that the whole word is existing. If this is the case, then I will return true. Like this I will search. Basically I am performing searching operation here. Now let us code this thing. Here let me create a function, public static boolean type function, because I am gonna return true or false. Start with start start with, and here let me give a string key, that is prefix. So prefix. Now in the program, first of all I will create a current node current is equals to my root. So I will store it with root. After that I will run a loop for int I is equals to 0 and I should be less than my prefix dot length. After that I plus plus. In this I will check if my current dot children value, that is current dot child idx. Before that I need to calculate the idx. So int idx is equals to my prefix dot caret that particular ith index minus a. So this thing will give me the index. Now at that particular index I am checking whether there is a character existing or not. If there is no character, it means that the character, for example that my prefix is bat. Now for the first character, if the first character is not itself existing, then it is not a prefix, right? So if it is null, if the particular child index is null for that character, if the index value is null, then I will return false. After that, else I will change the current value for the next character. So current dot child of that particular index. Here let me give the square brackets. Like this I will create my overall index. Now after running the whole loop, I am coming at the end of the level and I haven't written anything else. It means that the whole prefix is existing. If this is the case, then I will return true. Now in the main program, what I'm gonna do is that I will take two characters. I will remove all this. Now I will take two strings, prefix 1 and prefix 2. So string, let me give prefix 1 is equals to, for the given array, for the given character, let's set my prefix 1 is like. Now after my string 2, let us consider string prefix prefix 2 is equals to, let's say I am giving sun. Okay, now after it I will call the function. I will call starts with function, starts with, and I will pass first of all prefix 1, and similarly I will pass prefix 2. So starts with function for prefix 2. Now if I run this, then the first string, that is prefix 1, is a part of my given string. So this should give me, prefix 1 will give me true. Now you can see that prefix 2 is not part of my overall words array. If it is not a part, then I will return false. Now let me save and run. So you can say that I got the output first of all true. After it I will get output false, because the second prefix is not existing, is not a prefix of any word. Okay, now let's say that I'm only giving yes. So yes is a part of my tree. So if it is a part, it should return me true. You can see that I will get true and true. This is how we will basically check whether the given key or character or string is a prefix of my given try or not. This is how we will check. I hope you have understand. Now let us talk about another interesting question. So the name of the question is count unique substrings. So what is a substring? For example, let's say that this is the given string. Now if I calculate, if I extract the substrings manually, then my substrings will be substrings for this particular string will be, substring is nothing but a character which is a part of the given string, a set of characters which is a part, you can say a subpart of the given string, that is known as a substring. Okay, now the substrings for the given string, here you can say that the number of characters are 1 2 3 4 5. So here if I write the total substrings that can be possible for the given string is, first of all A can be a substring, after it B can be another one, after it similarly A B A, after it A B or B A, after it A B or B A. Now here I can take three characters, that is ABA or BAB or ABA, right? Or I can take 4 characters as well, that is AB or BABA, or I can take all 5 characters. Okay, so ABA or finally my empty string. Okay, so these are the total number of substrings that can be possible for the given string. Okay, now what I have to do is that I need to only consider the unique characters. So I will remove the duplicates. A is already existing, so I will remove it. After it, BA is already there, so I will remove these two. After it, here ABA is already existing. Now count the total number of characters, substrings I am having. So 1 2 3 4 5 6 7 8 9, and I will consider my empty string. So combining all this, my unique substrings will be 10. This is how I will manually calculate the unique substrings. This is the concept of substring. So user will give me a string and I need to tell how many unique substrings that can be possible for the given string. So how I'm gonna do this question? So to do this question, you need to understand the concept. That concept is, let me remove the ink, and the given string is A B A B. Now what I will do is that I will run a forward loop, and as I move forward, I will cut my elements into 2 different parts, and I will consider the second part as a substring. Okay, so what I will do is that I will take the suffixes basically. For example, let me show you that. So initially I will cut here, and my suffix here, it will give me the forward cut. You need to remember that the forward cut, if I break my array into 2 different parts and I am ignoring the first part, then the second part will be my suffix, right? What is suffix? Suffix is nothing but the end part of a given character. So here you can see that this is the character. So if I remove the first part, then the second part, the end part which I am having, will become my suffix. So A, for the suffix A B A B A. Here how many characters? 1 2 3, yeah, okay, 5. So this will be my suffix 1. Now after it, I will put a cut here and I will ignore it. Now this will become my another suffix. So B A B A, this will become my another suffix. After that I will put my cut on the next side. On the next character I will put cut. So I will remove B. Now the remaining characters will be ABA. Now ABA is also a suffix. After that I will put cut here, so the remaining character will be BA. After that I will put cut here, right? So final character will be A. After that again put cut, and I am left with empty string. Okay, so you need to remember one thing, that if I put a forward cutting, if I go forward and remove the first part, first character, then the rest of the string which you are having will be a suffix. Similarly, if I run a backward cut, if I remove the last part, then the rest of the elements which we are having will become the prefix part of your string. And we are gonna use the concept of suffix to solve this question. So how I'm gonna solve this question is that, first of all, I will calculate all the suffixes. So here the suffixes are A, B, A, B, A. After B, A, B, A, after A, B, A, I'm talking about the approach. So first of all, I will calculate all the suffixes. Now after calculating the suffixes, here these are the suffixes. So for this each and individual suffixes, I will calculate the prefixes of it. So the prefixes for this string will be A, AB, ABA, after that AB, AB, after that finally the whole string, that is A, B, A, B, A. So these are the total number of prefixes that can be possible. So what I am doing is that for all the suffixes, whatever the substrings I am getting, so this is a substring, this is substring, right? So for this suffix substrings, I will calculate their prefixes. So here I will calculate the prefix. B is a prefix, BA is a prefix, after that BAB is a prefix, after that BA is a prefix. Similarly for this string, A is a prefix, AB is a prefix, ABA is a prefix. Similarly for this, B is a prefix, BA is a prefix, and finally A. Now what I will do is that I got all the prefixes. These are all the prefixes for the suffix. Now I will remove the duplicates. So here I will remove the duplicates, 1, 2 and 3, 4, and yeah. Now you can consider that 1, 2, 3, 4, 5, 6, 7, 8, 9 and empty string. So this will give me my total number of substrings. So what I have done, I have put a forward cut and I have ignored the first element. So if I remove the first element, then the rest of the string will be a suffix. Like this, I have calculated for the given string all the suffixes. This is my first step. Now for all the suffixes, I have calculated their prefix. After calculating all the prefixes, I have removed the duplicates element. After removing the duplicate element, whatever the elements I am left, that will give me the total number of unique substrings. So this is the general approach. Now how we can insert the concepts of tries here? This is the question. So talking about how we can insert the tries, let us do one thing. So what I will do is that the step 1 is I will calculate all the suffixes for the given string. So the step 1 will be find all the suffixes for the given string, find all the suffixes. Now the second thing is that for that particular suffix, whatever the suffix you will get, create a try for that. So create try for all the possible suffixes, whatever the suffixes you are getting, right? Try to build a try for that particular suffix. So I will build a try for this. Now the third thing will be total number of notes in this try will be your answer. That's all. Now let us calculate. First of all, I will write the suffixes. So the suffixes for this, if I put a forward cut, then initially the cut will be here. So the suffix will be AB, ABA. After that I will put the first cut, right? So I will put cut here. So the suffix will be BA, BA, after that ABA, after that BA, and finally A. So these are the total suffixes, right? So I will try to build the suffixes, the total number of, for all the suffixes I will try to build a try. So initially my root node is empty. Now I will go to this first array, second string, third string, fourth string, fifth string. So for this 5 strings I will build a try. So here I am having A. So I will insert A, after that B, after that A, B and A. Now for the second string, the first character is B. So I will add B, A, B, and A. Now you can see that for the third string, the first character is A and A is already existing. After B is already existing, A is already A there. So no need to add. So the third string is completed. Now for the fourth string, the first character is B. After the second character is A, already existing. No need to add again. Now the fifth character A is already existing. No need to add again. Now after creating your trie, give the total number of nodes which you are having, and that will become the total number of unique substrings. That's all. So here how many number of nodes? 1 2 3 4 5 6 7 8 9 10, and that is your answer, right? So this is how we will calculate the overall unique substrings. Now if you go with brute force, then it will become so much complex. So what you will do, you will calculate some prefixes, store it in an array, and again do some operations. Here using tries, what we are doing, first of all we are calculating suffixes. For the suffix array, I am creating trie, and the total number of nodes in the trie will become my answer. That's all. This is the approach. I hope you have understood. Now let us code this thing. So in the main program, I have taken the example which I have taken in the program in the slide, right? I have taken the same example. Now the first step is I need to insert the suffixes into my given trie. So into my insertion function, I need to add that. So what I will do is that I will run a loop for int I is equals to 0, and I should be less than my I should be less than str.length, and after that I will increment I plus plus. Now in this I will create a string. Let's say that suffix is equals to my str dot substring. I will use substring function, and I will take the first character and I will add it in my suffix. So except the first character, whatever the string I am left, that string will become my suffix. After that, as I increase I will ignore the first part and I will only consider the last part. So this is how I will calculate suffix. Now after calculating suffix, here I need to give a bracket. Okay, now after calculating suffix, I will call my insert function for this particular suffix. Okay, now after that, what I will do is that whatever the function, I will create a function, and that function will count the number of nodes. So I will create a function public static int, and let's say the name of the function is count. Here I will pass my root node. So root node, and if the root node is null, if root node is null, it means that there are no elements, then I will return 0. Now here I need to give the total number of count, total number of nodes in my trie. So what I will do is that I will run for a loop. I will run for int I is equals to 0, and I should be less than 26, because I'm at max, I can, for a particular node at max I can store 26 nodes, right? So I plus plus. Now in this I will check for the root node dot children of ith element. If it is not null, then I will increment the count value. So let me create a count here. So count plus is equals to, I will recursively call for the rest of the array. So count plus is equals to, here let me give the count nodes as the name, because I don't want to confuse the integer and the function, right? So count node plus is equals to, I will call the count function for the next root dot children. For that particular children I will call, right? So whatever the children, the value returned by the children, I will add that into my count node, and finally after running the whole loop I will return my count node plus 1 value, because I will include the null value also, right? So this is how I will count the number of nodes in my whole trie. Now after that, what I will do here is that I will print system.out.print. Here let me print, okay, here let me print system.out.print, and I will call my count function, and here I will pass the root. Now let me save this and run. If I run this, then the output will be 10, because I know I have tried run this and I have showed you that the output will be 10. Now let me save and run this. So you can see that I got the output as 10. This is how we will calculate the unique number of prefix, the unique number of substrings that can be possible for a string, right? So one logic you have extracted from this class, from the end question, is that the total number of nodes of a trie will become the total number of substrings that can be possible for it. So whenever you see a unique total number of strings, then you should use the concepts of tries, and if he is asking the count, then you just print the total size of the try, right? And if he is asking you to print the node, then in the place of count just print the node value. This is how we will use the concepts of tries to solve complex string questions. Up to now we have covered overall concept of what is a try, why we use it, operations involved in it like insertion, searching, and we have solved some questions based on the concepts of tries. So with that being said, I will see you in our next chapter, and the next chapter is going to be very important and very interesting chapter, and the name of the chapter is graph. So with that being said, I will see you in the next one.